afternoon to all the dignitaries and panelists on and off the dais. So it's a pleasure to welcome you all to this important panel discussion on advancements in heavy engineering and energy as part of the Stainless Steel Summit 2025. So India's stainless steel sector, as you know, has seen some strong growth in the last few years, growing from a consumption of 2.7 million tons in 2020 to about 4 million tons in 2025. It has been driven by growth in infrastructure, transportation, processing industries, etc., and it reflects a growth in the material usage across sectors as well as the growing importance of stainless steel across the engineering and manufacturing landscape. So stainless steel currently plays a very critical role in heavy engineering, be it in oil and gas industry, where pipelines, offshore platforms, etc., or in chemical and processing industries due to corrosion resistance and mechanical properties, in food and beverage sector due to its chemical inertness and suitability for sterilization, and even in marine and coastal applications. Now, as we all know, India is at the cusp of a transformative growth journey. India is targeting to achieve almost 500 gigawatt of renewable energy by 2030. Similarly, 5 million tons of green hydrogen production is also on the horizon. And in all of these, stainless steel plays a very critical application because of its essential properties like being, lightweight, corrosion resistant, uh, having good mechanical properties, etc. So today's discussion brings across leaders from different fields of stainless steel industry, from global business heads to R&D and engineering experts and scientists. And in this session, we expect to have fruitful discussions and exchanging of perspectives and ideas about the current role and the future potential of stainless steel industry. Uh, I think my introduction is done here. Now, first of all, Dr. G.H. Thanki, sir, you would like to make some small speech?
Good afternoon, everyone. It's a privilege to be part of this distinguished panel today to discuss advancement in heavy engineering and energy. These two sectors, intrinsically linked, are the bedrock of global infrastructure and economic growth. We are living through a period of unprecedented transformation driven by technological innovation and an urgent need for sustainable solutions. Examining heavy engineering, we are witnessing a fundamental shift from muscle to mind. The machines that once solely represented brute strength are now becoming intelligent, connected, and increasingly autonomous. Key advancements include digital transformation and four-number industry. The integration of AI, machine learning, IoT, and data analytics is revolutionizing operations. We are seeing greater efficiency, predictive maintenance that drastically reduces downtime, and enhanced quality control through machine vision. Digital twins are allowing for real-time monitoring and optimization of complex industrial process. Advanced robotics and automation. Robots are not just automatic, repetitive tasks, but are also becoming more collaborative, working safely alongside human operators, and this enhances productivity and safety, especially in hazardous environment. And additive manufacturing, that means 3D printing, this technology is moving beyond prototyping and is now playing a crucial role in mass customization and reducing material waste, with application even extending to construction and aerospace. Sustainable energy, there is a growing emphasis on green building material, eco-friendly designs, and circular economy models that promote reuse and recyclability. This is vital for reducing the environmental footprint of large-scale projects. On the energy front, the landscape is equally dynamic, with a strong imperative towards decarbonization and diversified energy sources. Renewable energy dominates, advanced energy storage solution, green hydrogen, nuclear energy, evoking the matter, and AI powered smart grids. AI is enabling real time monitoring, automated responses to grid substances, better prediction of equipment failure, and more seamless integration of diverse energy sources, all while bolstering the cybersecurity. The convergence of these advancements presents both immense opportunity and complex challenges. We need to focus on interoperability and data security, skilled workforce development, policy and investment frameworks, and ethical consideration, especially with AI and automation. We must consider the ethical implications and ensure responsible deployment. One only. I believe that by embracing these advancements, responsibility and strategically, we can build a future that is not only more efficient and productive, but also profoundly more sustainable. I look forward to a stimulating discussion with my fellow panelists and audience. Thank you, sir. Thank you.
Thank you, sir, for that insightful speech. So, starting the panel discussion. So, I will go one question to each panelist, starting with Mr. Deepak Vaidya, Business Head, Autocompo India. So, sir, with India's stainless steel consumption growing steadily over the last 5 years, how is Autocompo aligning its strategies to meet the evolving demands of sectors? If you could you provide an opinion on that.
Thank you, Anvesh. I think a very valid question. Uh, well, we never changed our strategy right from day one. We started in India way back in 2006. We have been very focused. The strategy for India is that we will address the corrosion issues in India and try to mitigate that. Coming to oil and gas industry and carbon footprints, as a company, Autocompo is very much concerned about the sustainability. A few facts like Autocompo is the only company in the world in stainless steel who has signed the 1.5-degree SBTi targets. Our carbon footprints are 70% lower than the global industry average. And Autocompo is the only company who is offering the product specific carbon footprints, including scope 3, which means that every coil or sheet that we produce and sell, the customers has an advantage that the CO2 emission to produce that particular coil or sheet is being reported on our test certificate, which customer can take into their scope 3 calculations. So our calculation goes that like the customers who buy from us, we help them in saving roughly 10 million tons of CO2 emissions every year. So the core is that yes, sustainability, right product at the right place, corrosion mitigation, that has been our strategy.
Thank you, sir. So sustainability currently is very important. You know, most of the companies are moving towards BRSR reporting. India also has a net zero carbon strategy by 2070. So in that case, like Deepak Vaidya sir said, stainless steel can play a very important role in decarbonization of this sector. Moving on to the next panelist, Mr. Ashish Saraf, Business Head, EPC Division, Evolve Green Energies. Sir, you come from the EPC industry. So, from an EPC standpoint, how has stainless steel played a transformative role in executing renewable energy projects like solar, wind, or hydrogen ready infrastructure? If you could provide your views on that.
Thank you, Anvesh ji. It's an absolute pleasure for us, Evolve India, to be present here at GSSE 2025. Coming to your question about solar in the use of stainless steel in the solar industry or in the renewable sector. So if I were to talk about solar alone, uh, in case of mounting structures, SS304 is a standard norm now, which we use regularly in case of mounting structures for panels. And especially in cases of high humidity coastal zones, SS304 for solar mounting structures has become a integral part. Apart from that, when we talk about solar water heaters, stainless steel is the product of choice over other forms of mild steel or other steels because of the longevity. You know, we are looking at 15, 20 years of life cycle. Talking about wind energy, a lot of our towers, wind energy towers, are having SS as an integral part. Apart from fasteners, ladders, safety rails, are all made of SS. In fact, I would like to bring to your attention that India is going to go very big on offshore wind projects, especially in the states of Tamil Nadu and Gujarat. And their duplex stainless steel is going to be in a very huge demand because that is the product of choice. Coming to wind energy, coming to hydrogen, absolutely all electrolyzers are of stainless steel. The storage tanks are stainless steel. And in fact, the hydrogen mission, which is about 20,000 crores by government of India, gives us very specific mandates that we should use anti-corrosive material, and again, stainless steel is of choice over other forms of steel. So I hope that answers your question.
Right, right. Thank you, sir. Thank you. So, as sir has rightly said, India is really seeing a growth, vast growth in its renewable energy sector with a focus on hydrogen. And stainless steel can really play an important role in navigating these complexities. So, my next question would be to Dr. Mrigesh Verma, Head R&D Raj Tubes. So, sir, what are the key R&D priorities at Raj Tubes today to make stainless steel more adaptable to harsh industrial environments? If you could provide a view on that.
So at Raj Tubes, we as a manufacturer of tubes, we have control only on the manufacturing of the tube. From steel manufacturer, if you get even the most cleanest of the steel and you weld it poorly, so then it won't be of any use. So we continually keeps on improving our welding processes to get the best out of the steel and minimize the weld zones or heat affected zones, which are the key failure points in a steel structure. And we also the main reason of the restriction in adaptation of stainless steel is the cost effectiveness of the or the initial cost of the material. So this can be tackled by the reduction in the weight of the steel used. The stainless steel being of a relatively higher strength, we can save some weight and offset this initial cost, and that 40% or 30% cost can be minimized to 25 or 20% cost difference from normal steel to stainless steel change. That's what we are optimizing. And we also optimize our cold working processes and annealing processes to get the finest balance between the strength and ductility, and even control on the grain structures that are of key importance of in the strength and lifespan of the steel.
Thank you, sir, for that insight. Moving on to Dr. G.H. Thanki, Director and Principal Consultant, Corrosion Control and Monitoring. Sir, stainless steel, people have a common perception it is rust, it won't rust at all. But you are a scientist, you have vast experience. In your experience, what are the most common corrosion challenges in heavy engineering sectors, and how is stainless steel helping overcome them in Indian context? And whether it doesn't rust at all, or you would like to break the common public perception that it can rust, but there are situations how to prevent it, please.
Thanks for such a basic question, sir, really. A lot of misunderstanding prevails in the technical society as well as the common people. Infrastructure, for example, we talk about of heavy industry, certainly is facing a very serious problem. First foremost is the fabrication mode point of view. It leads to the localized corrosion, crevice corrosion, pitting, and when it is facing the salinity, humidity, it leads to the high corrosivity in that case, sir. And in that case, naturally, first line of defense is the coating to be applied. But when we apply the coating, we hardly wait for proper surface preparation. Even the saying goes that a good surface preparation, the 70% of the failure or success depends on the surface preparation. Any bad paint can go very well if surface preparation is good. But we are not very much having such patience to wait for that surface preparation. That's first foremost thing, sir. Second thing, the cathodic protection can be applied if humidity is available and it is submerged, then it is applied. Third is that proper inspection procedures to be adopted to look into it, that any mishaps or discontinuity has taken place in the fabrication. Third things are that corrosion monitoring has to be carried out regularly. As always I say that corrosion is a natural phenomena. But we forget what we say. Natural phenomena means it is following the strict instruction in nature. Nature means what, sir? Either it has to be sustainable and second thing is discipline. For example, sun rises every day since billions of years, but that is not sufficient. It rises at the right time. It is nature. My and your heart trembles, but it has to be go with accurately till we last breath. Like that, corrosion has to be controlled. Same consciousness. Painting is done has to be inspected every regular way. Otherwise, corrosion never will stop. That's why corrosionists we always say corrosion never sleeps. But then you have to also remain unslept in that case, sir. So that's it. Corrosion has to be controlled by the nature, and you have to follow this. And stainless steel definitely give a lot of weight to that, as we have always appreciated corrosion. But as a corrosion man, I say we appreciate stainless steel. So far as that product has been made by the people like the people at JSW, they are making very good material. But afterwards, that you are not using that plate. It has to be formed. It has to be welded, and there this negative points enters in. We say that the JSW has not made good steel, but we do not say that how it was fabricated, how it was, its basic norms were never observed, and that's why it fails. So stainless is fine, but we have to concentrate more on the how we fabricate and how we expose the system. I think, sir.
Thank you, sir. Very valid points mentioned by Dr. Tanki. So my next question is again to Mr. Deepak Vaidya. Sir, in your opinion, what policy support do you think is needed from the government to boost stainless steel consumption in India? Since you are a global steel manufacturer, what policies do you think we can adopt from other countries? If you can share a point of view.
Okay, so there are two perspectives over here. Just give you a figure, like the latest figures that we have is like the last year the production of stainless steel melt production was close to 4.5 million ton, and apparent consumption was 4.8 million tons, which means consumption is growing. Second thing, we have seen recently last 2 weeks that we have become the fourth largest economy in the world, and there is a debate going on. It's a per capita consumption or something that I would. We have to look into the basic facts why this is happening, because the Indian fabricators, they are getting more and more global projects. They are doing the value addition. So if you talk about the production of stainless steel, what I see is government should emphasize on one thing, that is increasing the downstream production, supporting the MSMEs, educating people to come and start fabricating stainless steel to the global standards. As far as the consumption is needed, that is, I think, mostly to do with the common mindset. Of course, government is doing whatsoever they can. They are coming up with the policy decisions. But as a customer or citizen, we have to understand that stainless steel is good for us, not on hygienically, but also the life cycle cost, which is the lowest. So we should start demanding those products. And your third question was related to the policy. The easiest policy decision that I can think of is like government is talking about the green steel. They should put the same conditions even for the import of the steel, like if like, and they can put in the condition, okay, you declare your carbon footprints, and if the carbon footprints are higher than this level, then the material should not be allowed in India. So that is one thing, and that is how we develop the ecosystems in India. Because the fact is, we cannot make India as a dumping ground for the inferior or second choice quality.
Very well said, sir. I think Ministry of Steel is already taking certain initiatives in that direction. Uh, After implementation of CBAM, India is also exploring ideas as to how can we restrict import of low quality steel, like sir has said, and they are planning to introduce melt and pour clause in the recent DMI and SP policy. They have said that the steel should be melted and poured in India instead of being imported by countries which have an FTA. So these kind of initiatives can go a long way to support the domestic stainless steel industry. Moving on to the next question, sir, to Mr. Ashish Saraf. Uh, what do you think from an Indian EPC company point of view? What are some of the challenges and opportunities, around cost competitiveness or material availability when transitioning to stainless steel based energy systems?
Yeah, that's a good question. I'll talk about material availability from a solar or a renewable energy point of view. So the last that we checked was that India is already producing something like 4.2 million tons of SS. So availability of stainless steel is not a very big challenge for us right now. But like I told you in the previous question, that the availability of duplex stainless steel seems to be a little difficult, especially given that it's dependent on imported nickel and molybdenum. We've been given to understand that government of India is working closely with the ISSDA and some major steel manufacturers like Jindal and SAIL to ramp up production. Uh, as an outsider, I'm given to believe that. Coming to the cost competitiveness, what we have seen using stainless steel works out to be about 2.5 to 4 times more expensive as compared to other forms of steel, maybe GI or mild steel. But given the life cycle cost savings, stainless steel has become a choice, a number one choice for the renewable energy sector. And we strongly feel that the demand for stainless steel in our industry is only going to rise from here.
Very valid point, sir. Very valid point. And also, like you said, I think this has been discussed before also. The life cycle analysis, the life cycle cost should be made mandatory in some cases, because to ensure that, materials with with better longevity can enter the game, even though they have a higher initial cost. And sir, I think this scrap, the scrap that is generated from stainless steel, that will also be valuable because it has a better longevity. Right. Moving on to the next question to Dr. Mrigesh Verma. Uh, Sir, how can we, this is from an R&D perspective, how do you think we should collaborate more globally with global players? Have there been any successful collaborations with academia or global partners for, to accelerate the product development or such facilities in stainless steel? If you can share your insights on that.
Uh, at Raj Tubes or Raj Ratna, we currently don't have any standing collaboration in academia, but there are plenty of researches going on in IITs and NITs and other research institute also. One of the examples is from NML. They are extensively working on enhancing the properties, allowing conditioning and making new grades of stainless steel. Even for I guess IPR, they had made a special grade of stainless steel which is uh, absorbing a higher amount of radiation compared to normal 304. They had developed in I guess in France. They had developed that alloy. So such kind of academic involvement is always necessary. And at Rajtube, we also welcome any kind of academic involvement and collaboration from an academic area is always necessary. From an industrial perspective, we have some rigid points or some limitations. But when we go to the academia, they can go beyond our thinking. And even also, they have a sophisticated instrumentation, sophisticated testing facilities. That can be used for validation and formulation of better chemistries and better material for future usage.
And in this regard, what I would also like to mention, Ministry of Steel is also focused on this. Recently, they have relaunched the SRTMI initiative, Steel Research and Technology Mission of India. And one of the focus areas is, solving stainless steel related problems, inviting startups for solving some of the problems that we face as an industry. So this will be something interesting to watch out for. Moving to the next question to Dr. G.H. Tanki. Sir, like you mentioned correctly, regular monitoring is very much required for stainless steel. If you can elaborate a bit on the role of predictive maintenance, then corrosion diagnostics in extending the life, and how do you think would be the cost implication? Because stainless steel is already costly. If I am to carry out very regular monitoring, would that increase the cost very much? If you can share your point of view, sir.
So in this context, I would like to redefine the word costly. It is not costly, it is valuable. Right, sir? For example, a car worth of about, say, 8 crore rupees is definitely costly for us. It may not be costly for the Ambani's group. So, utility value. Stainless steel is not costly, it is valuable. But when we talk about we should think about RCC and LOI, life cycle cost and return on investment. If ROI is good, I think it is far better than carbon steel. Anybody with a only logical you can say it is definitely cheaper. And life cycle cost will naturally quite less than you consider stainless steel. So that is one point, sir. Second thing, the application of stainless steel keeps away from many grudges. For example, unexpected downtime. Second thing, it will not fail because it has been told no that carbon steel gives its way because of its own product rust gives away and makes it thin. As against stainless steel, it maintains its own percentage along with it. So carbon steel gives away because of it is being not supported by the product. That is the beauty of stainless steel carbon steel. But only thing, though it may be a little away from your question, sir, is a corrosionist. I think odd man out because we always talk about the stainless steel is we are appreciating anything. But again, I'm worried about the stainless steel versus get fabricated. We forget many norms. Many people do not know, sir. JSL people also might not be not will be unhappy in that case because which type of electrode to be utilized when to be fabricated. People use the wrong type of electrodes. Then the current to be applied. Then, for example, stainless steel is very prone to pitting corrosion, galvanic corrosion. No doubt in the galvanic corrosion, it consumes carbon steel at its own cost. Then the crevice corrosion. All of the problems are with not stainless steel, the way it has been made. So I think we should make people clear that stainless steel is quite good, but fabrication method have to be understood. And it requires a lot of education, not only to the common man, even the fabricators, even the engineers who are there, because I have come across in my 45 years of span is my subject. I have understood I have really taken with a pinch of salt. So why people are not understanding the basic aspect? I think the stainless steel is definitely valuable, sir. It's not costly. I think it is that way, what I understand.
Excellent point, sir. Excellent point. My next question to Mr. Deepak Vaidya. Sir, uh, as we know, rural sector in India has relatively lesser steel consumption. How can we promote more stainless steel consumption in the rural market? You mentioned we need to change the mindset. How can we do something more about that? If you can please give a pointer.
Okay, so we need to figure out some of the applications. And like I say, one thing is we are looking at the stainless steel water tanks, and we do see that in the rural areas. And yesterday I was with someone, I was telling me that now in some rural areas, the people who are putting up the stainless steel tanks on their roof, it's not because of the hygiene only. That is probably 5% of the consideration. It's more to do with the prestige issue. So I got that because he's manufacturing those tanks, and I think, but that will bring a shift. But what we can do more in the rural area, we know we have a big problem of the food rotting in India, and the storage and distribution is an issue. So government can think of putting up those grain silos for storing in the rural areas that can prolong. What you can have is basically the plumbing pipelines or fresh water, because we see in the rural areas, some of the places the people do not have access to the clean drinking water. So some stainless steel piping can be done. And more, what I see is important in rural areas because that makes the economy, the agricultural industry. So you need to create the complete value chain, the cold storage of that, the complete infrastructure. When we talk about infrastructure investment by government, we normally think it is only the bridges, highways, and that's all. But what government is talking much more than that. When they're talking about the industrial corridors, it means suppose from Mumbai to some XYZ place in Vadodara or maybe Ahmedabad, if you have some villages, you may create some tank farms over there where you store the coal, you store the chemicals. That is also a part of the rural development. And maybe you're into solar, but I think that some investments can be done in the rural areas on the solar, where you have big ponds, you can put up the floating water, the stations. He mentioned about that issue of humidity in the coastal areas, but I think in the non-coastal areas, we have a lot of traffic. If you go to Delhi or villages near Delhi, you have a carbonation problem that also create a problem. So more is to do with the education is more important, because it's not only the end user, but the manufacturer, the EPCs need to get educated. I've seen that people are talking about duplex, but most of the places people are not using the right grade of duplex stainless steel. Either it is overspecified or underspecified. That's why the cost issue is there. I'll just go out of for 2 minutes for out of the rural. We mentioned about the life cycle costing. A life cycle costing has been done for carbon steel converted to super duplex stainless steel. Initial cost 7.5% per kg extra for a crude oil storage tank. See, and why super duplex? Because in India, we have a typical problem at the coastal areas, temperature go up to 45 degrees. But what you do in the carbon steel, you are coating it. So you don't need to coat carbon steel, this super duplex. And if you add up that cost, you reach at around 5%. From 7 to you reach 5%. Now, what does the code says? The API 653 code for storage tank says that if you are maintaining a storage tank or you're doing the inspection after 10 years, if you're using stainless steel, you can increase that by 10 years. So practically, you have an advantage. So for 30 years of life, you are inspecting it only twice. So end calculation, if you do just on that basis in 30 years with the practical available data on the government website, the super duplex, which is 7.5 times costly than carbon steel, your 30-year life cycle is 50% less than the carbon steel. So that is the right selection of the material and proper calculation mathematically with the scientific formulas. That is important to be done. And same thing can be done in the rural areas, how much you invest in them.
Understood, sir. Very valid points. Uh, I will move on to the next question to Mr. Ashish Saraf. Sir, steel sector and India as a whole is going towards, greening. So how can stainless steel support that? So can it help in, say, hydrogen sector? How can it help in other sectors? If you can provide your viewpoint on that.
I'll talk about the steel sector in general and how we at renewables look at the steel structure, not so much on the stainless steel part of it. The data that our industry associations have shared with us is that about India is one of the top three producers of steel in the world, and we are also in the top three consumers of steel in the world. But unfortunately, the steel industry uses less than 1% of their energy requirements from renewable sources, which is admissibly low. So even while many of us, even in this room, may be working or being associated with very large stainless steel manufacturing, and some of you may be having captive energy plants, which mandates that you have 4.5% of all your energy requirements from renewable sources. But in the real sense, that is not happening in the uh, steel industry so much. On behalf of the renewable energy sector, I appeal to all of you that please look at renewables as an extremely cost-effective uh, source of energy, where the payback period can be as low as maybe 4 years. Like our company, Evolve India, we are promising 3.5 years of payback period. Financing by the government is extremely lucrative. There are many new schemes which we can talk about offline, which the government is promoting for you to go green. So now the ball is in actually the uh, in your court, where you have to choose to go green, and many of the industry leaders have actually benefited from this. So, talking about the stainless steel industry in general, there is a lot of takeaway from the renewable sector. Is just that maybe at times education or information is lacking, or maybe sometimes the willpower is lacking. But if we can collaborate with the sector in general, I'm sure there is a lot to gain for both industries together. Thank you.
Thank you, sir. Moving on to the next question to Dr. Mrigesh Verma. So, sir, what are your expectations? By you, I mean the scientist community, R&D community. Your expectations from the larger ecosystem to support the innovation pipeline, say in terms of government labs, common centers of excellence, funding, standardization? If you could throw some light on that, sir.
So from the R&D perspective, first of all, we have to start from the grassroots levels. As everybody said, there is very less education available or very less knowledge available on stainless steel. If you go to some solar panel installation person, which is doing at domestic level, at a home level, they will come and say, I'll use 304 anchor fastener and I'll make a structure from GI. That is a total nonsense thing. It is so this kind of educational mishaps are there. There are many. This is a small case. There are many such kind of things at design level, at other study level, that people are not aware of how to use a proper grade of material, not only stainless steel, but any grade of material. They are using whatever it is available, and by use of Google, it's becoming worse. So the institutes from the grassroots, from ITI, diploma, graduation, uh, the entire education needs to evolve based on this, and give specialized training, especially to welders. There is a scarcity of stainless steel welder in industry who can weld a very good weld, uh, but that can be trained. There is a recent workshop also going on the welding in this premises only. Such kind of education, such kind of skill development is necessary, and regulatory boards and the entire ecosystem needs to focus on that while growing the requirement of the stainless steel in the industry.
Thank you, sir. Next, I'll move to Dr. G.H. Tanki. Sir, I think a similar question on similar lines. What kind of policy changes or industry approach changes would you recommend to mainstream corrosion science or sustainability thinking in the such stainless steel industry?
Without going much of the references available that how people are doing about the corrosion awareness, if I tell you my own experience, I started this PG diploma course in corrosion technology in MS University since I am from Baroda, and it has got good momentum. So we got it good qualified people, those who have passed a master degree, and further 1 year to go. So that is with the university. Second thing that it was also practice university industry interaction program, in which the universities are being connected by the industries with their problems. They talk to the concerned engineers over there, and then again the level of this understanding of the subject will be quite good, and the students who are coming out from the university, they'll be better placed when they go in the industry. That is the second thing. Third thing, at the moment, this JSL is with me, and they are doing a lot of work in educating. For example, they are working very closely with our CII CMD. I am the part of the CMD since last 2008, and we have conducted many courses in India. We have developed the corrosion manager course. Corrosion manager course means it will be interesting for the audience to know, sir, because many times, no, for example, a coating contract has been given to some people. They are doing coating structures. Now there is nobody who knows about the coating in the plant. So the mechanical engineering will be interested in the work. Please go to the in the end of the day. Please see, and as per your certificate, we will pass on his bill. Now that mechanical engineer does not know about coating, what to inspect. He has not been taught in the university as well, not in this law. So we developed in CNCII corrosion manager course. There's a 3 days lecture series. We make people understand what is corrosion is about, coating and water and energy we develop. I think you might be aware about that, sir. And I have conducted this one maybe more than 35 courses in the country we conducted, sir. And we got good result. Now we are every year 75 boys throughout the country where I as a faculty talk to them of various corrosion subjects. So our crucial is there, sir. So this is the way one should develop. And I think this our conductors of this particular organization, they also should start. I was talking to them also. Why shouldn't you go with? I am there with you to develop, sir. I think this is the way we can develop the matter, sir. Unless educators are there, corrosion is going to remain its defined corrosion is rust. That is all. That is the case, sir.
Thank you, sir. Moving on to the last round of questions. Sir, last question for Mr. Deepak Vaidya, sir. I think, recently, in the recent past, Indian government stakeholders or even EPC companies, they are moving for more localization and import substitution. What is your take on that? How do you think, Outokumpu or other stainless steel companies are adapting to that from a supply chain standpoint?
Yes, government is taking so many initiatives, and I would say it's not only about the localization, but make in India for the globe. That is the right perspective. From Autocompo side, what I can say that we are here to partner. That's what I started with. We are not dumping any material, and our focus and strategy has been to educate people, address the corrosion issues, and do something new, which as of now India is not doing, and let the industry learn from us because we have a heritage of 100 years. We talked about energy, recycled. Uh, as of now, stainless steel is 100% recyclable. And if I'm correct, the global industry recyclable average is around 60%. In Autocompu, our recycled content, in spite of having chrome ore mining, it's more than 95%. And the non-coal based power or renewable power that we use is more than 85%. So that is the strength. And I think the industry should learn from that. And you talk about localization. Yes, Dr. Tanki talked about the education that CICMs is imparting. And I'm also honored that I'm a part where I'm teaching the new materials parts. That's how we are educating the industry. What is more important, we need to do much beyond that because CISCMC is conducting that course and there is a fee for that. And I think the people in MSME, which is the hub, I'm not talking reaching even the SMEs. No one in MSME can afford to pay that fees. So we need to get into that level if we have to educate. And I see some associations or some organizers or some body should come forward, or maybe we do some collaboration, or the people who are actually concerned about sustainability corrosion, we collaborate together and do free sessions for the people in MSME. Because something what we have learned we need to impart to the society, that is the minimum we can do. And if we are able to do that, I think then we upskill the people over here and make a change in India.
Just one point, sir. In connection with Autocompo, I have got a quite good close relation with Autocompo way back in 93 to 97 when I was with GSFC, Gujarat Fertilizer. I was the head of the R&D and head of the corrosion engineering department. At that time, I had come to know when my first visit to Autocompo in Sweden, and I had seen that how the new products are getting tested in various media. And I could see that these are being done in laboratory with a confined parameters, temperature, pressure, like that. I raised the question with Mr. I forgot the name, sir. He was the marketing chief. I asked him that is it sufficient because this is not the area in which plants are functioning. Then he told me that where we can carry out such type of experiment. I told him so. My GSS is open for you. And after 2-3 visits, it was happened so that I coined new program, corrosion resistance compatibility screening program, CRCS program. We received material from abroad. We entered in the say, non-confidential that because of certain materials are expected to fail. I mean, the fails made known, then makes difference to their reputation. So we entered in that one, sir. We received 18 class of material. We operated in the process plant, phosphorus, sulfuric acid, caprolactam, melamine. And whatever the results were made available to us in laboratory, we give it to them. And it was quite important for them to make the necessary metallurgical changes. And we got a certificate, no doubt. We got 45,000 pounds from you, not dollars, pounds from you as a consultancy fee to GSFC. That means industry and the manufacturer can work together. There is a good knowledge sharing, sir. We did it. And still today, I remember the photographs are with me with your people, those who have come there. So this is the way I think industry and university and the R&D can work together.
Thank you, sir. Thank you very much. Sir, moving on to the last question to Mr. Saraf. Sir, can you share some insights about the upcoming focus areas or project opportunities that is accelerating, that is going to accelerate, stainless steel adoption in the energy domain?
Um, Upcoming projects. Actually, I'll just continue with what Deepak ji just spoke about government initiatives. See, to be frank with you, government is doing everything under the sun for literally under the sun for the solar industry to grow. So one of the biggest examples can be this latest PM Kusum Yojana. Okay, so in PM Kusum Yojana alone, government is installing 30 lakh solar water pumps. Now, each of these pumps, you may be knowing, the body is made of stainless steel. Okay, so this is a very, very small example I've given you about the scope of stainless steel in the renewable energy sector. There are many such schemes, NTPC is coming up with so many hydrogen projects in remote places like Leh Ladakh. Many government schemes are there. It's for the industry to take initiative, come forward, come up with innovative products, and the sky's the limit. And to end it, actually, Anvesh, I think you are an expert on this. This latest taxonomy of steel, this government initiative where they have actually gone ahead and defined green steel. Okay, I'm not talking about stainless steel as such. I'm talking about steel in general. There is a very big initiative the government is taking on defining what they mean by green steel. Again, the money is not a problem, research grant is not a problem. The steel industry, the stainless steel industry needs to come forward, like Dr. Saab said, that get associated with academia, and a lot of new projects, a lot of new schemes are coming from the government sector where there are opportunities are actually limitless. So please look up what Niti Ayog is talking about, and the sky's the limit. Actually, thank you.
Thank you, sir. Indeed, the Ministry of Steel has been defining the green steel taxonomy, which is a very first of a kind initiative across the globe. Everywhere people keep talking about green steel, but Secretary Steel sir said that I want to define what is green. How do I define green? And that's the first step where we go towards more greening and decarbonization. Last question for Mr. Dr. Mrigesh Verma, sir. How do you think we can leverage material science or metallurgy to innovate, further stainless steel tubes for hydrogen applications? Because, there are problems with embrittlement, resistance, safety, etc. How can we do more? Your point of view on that, sir.
Yes, stainless steel already finds its application in hydrogen field, but as you said, the embrittlement is the prime aspect which is restricting it or limiting its usability over there. So we need to closely collaborate with the stainless steel manufacturers and academia for developing specific alloy conditioning of material, and also making a process parameter of, which can give us a much more denser and thicker passive layer on the surface, which will help us preventing this hydrogen embrittlement in the containers or tanks that are being used.
Okay. Thank you, sir. And last question for Dr. Thanki. Sir, with there is some rising awareness on life cycle assessment, asset longevity. It is gradually increasing. How do you think companies should integrate corrosion monitoring systems in their stainless steel based infrastructure?
Oh, great question, sir, really. Corrosion monitoring, I will give it as a baseline where I have faced very serious problem. Because as I say, including ourselves also, man is not reliable. Right, sir? Because he is being controlled by the mind. And when you are to collect a sample from the cooling water for a tower, and from the cooling water analysis, you are to select what type of treatment program should be given or what type of policy should be decided. Because one day this sample boy comes before lunch, collect the sample. Afterwards, when it comes, his mind is different. Then 2-3 times, for example, he's getting the pH say 7.8. 3 times consistency is 7.8. Then if 4 times will not go, he note it down. But at that time, somewhere he takes it as leaked and pH has gone down to some acidic line. But then additionally same. In that case, reliable is the continuous monitoring. With the now new technology, electronic system, and now AI has come in the picture, so reliability factor has gone high. So online real-time corrosion monitoring system has to be relied upon. I am telling, मैं कहूँ आंख न देखी सी बात है, क्योंकि way back in 81, I imported this online real-time corrosion monitoring system from UK, Hormone Limited. At the time, one system was costing somewhere 10 lakhs rupees. And 80, 81, 10 lakhs was a big thing. I had to have very frantic follow-up with the board. I had to make a presentation to justify why corrosion monitoring is important. Fortunately, at the time, that Caproton plant, GSFC, first of its kind in the country, in Poland, one heat when distillation column has fallen down because suddenly that formic acid formed, formic acid, and corrosion was safe share of the welding. And then I got a support from management. Let's please go there. And we could carry out corrosion monitoring system. So what I meant to say, sir, online real-time corrosion monitoring system, first thing to be applied. It seems to be a little costly, but again, LCC is less. Life cycle cost is less because you're averting unsafe operation, quality problem of the product, downtime of the system. So corrosion monitoring first thing comes in. Now in these days, since last about a year, AI, and then the Internet of Things and the data bank have come so important. So I think this is that we are very lucky that we have got such system with us. And we as corrosionists, we are really happy that yes, something has come. I can, before it happens, I know what is going to happen.
Thank you, sir. Thank you. So we have heard from all the eminent panelists. Now I would like to open the floor for audience questions or comments. If anyone would like to share any idea, please, sir.
Thank you, all the panelists. My comments or questions are to Mr. Saraf. Thank you for your talk on the renewable energy. I've got two things to say. You mentioned about 4 or 5 verticals of renewable energy or alternate energy and usage of stainless steel. In the solar water heating industry, which has been there, I think Tata BP Solar was one of the first to start in early 2000. The water tanks were being made of stainless steel, and some people use 304, 304L, and there was a large mushrooming of those companies. And suddenly we found, and if it is still true, that the solar water tanks were stopped being made out of stainless steel and switched to ceramic coated carbon steel. So, since you are saying that stainless steel is a first choice material for all this, are there any regulatory measures on this? The second thing is you talked about green steel, and of course, Deepak talked about it. Now, green steel, if we are using hydrogen, then it has to be green hydrogen, which means to generate hydrogen, we should use green power. But the challenge there is how do you store and transport hydrogen safely? So these are the two things I just wanted to, it's not a question, but the first one definitely is a question. Thank you. By the way, my name is Rao, with some 30 odd years of stainless steel experience.
Thank you, sir, for your question. So very quickly, MNRE, Ministry of New and Renewable Energy, has been updating its guidelines on what goes into manufacturing of a solar water heater. And fortunately, yes, they have defined the material that is to be used for the manufacturing of a solar storage water tank. The problem creeps in when newer technology comes in and it starts getting imported. And for applications in the private sector, you'll find a lot of ceramic stuff that you spoke about. But still, thankfully, in government projects, many of the government institutions are insisting on SS, the first part. The second part about green hydrogen, uh, it is born out of something called as green ammonia. Right. So, yes, transportation of hydrogen remains a very big challenge. India has done a number of trial projects in Maharashtra, in Jalgaon. There is a project that is going on. So green hydrogen, basically, if I understand correctly, is that the electrolyzer, if it is using power source of green energy, then it is green hydrogen. Easier said than done. Hydrogen is not stable. That's why we go into ammonia, and it's a evolving technology. I'm sure in the next 3 to 4 years, India will make big strides in this. IOCL, NTPC are some of the companies which are moving very rapidly into this space. So it's something to watch out for, sir. Thank you.
Thank you.
Question for Dr. Thanke. In the case of a green hydrogen, the electrolyzers which are used, the vessels used for electrolyzer, do you find any challenges for corrosion of those electrolyzer vessels? What are the challenges in that?
Nickel to be plated with a thin nickel. It has the project has been given by the Adani to us. So the electrolyzer for that when as it going on, and definitely it has got many obstacles because of it is first time in the country we are trying to touch that subject. That electrolyzing, giving a nanolayer coating on the carbon steel base, and again we have to see that the consistency of the nickel coating or nickel plating plays very important role, sir. If we fail, then total system made out of say it cost about 3.5 to 4 crore rupees, then the assignment will not be clear. But making electrolyzer with the system of electrolysis is quite challenging, sir.
Thank you, sir.
Thank you.
Sir, to address your question and to supplement, we know a UK-based company and also a company in Bangalore who are using 316L as a material for electrolyzers. So I'm just saying that.
Look, stainless steel as a substrate for nickel, or nickel as a substrate to the stainless steel. Compatibility has to be looked into, and end use has to be decided in which area you want to utilize. If it is a nickel base, then naturally so nickel is very much prone to certain halides. As against it is quite compatible in the alkaline condition. So again, the environment plays very important. Which one you would like to use the substrate?
Thank you.
So
Many
more
times, no, sir,
questions?
we say, no, I very, sometimes such question innocently people are asking, sir, platinum gets corroded, gold is corroded, but they do not know what type of environment they are asking me. You see, nothing is permanent in this earth. Like that gold also can be affected by the aqua regia. Your gold ring can be affected by the mercury. Then would you say so that gold is useless? No. What type of environment you are talking about? We are very comfortable in this environment. But suddenly AC goes away, we are becoming uncomfortable. It doesn't mean that we are comfortable. Environment plays an important role, no? So many times questions are half. So that's why they say, no, I will not compare. The saying goes, no, that even a villager can confuse Einstein. One villager can confuse Einstein. It doesn't mean that Einstein is not knowing anything. It is up to the person who is raising the question.
Thank you, sir. So finally, thank you to all the panelists once again for that enriching discussion and those insightful remarks. The way forward is we should all come together from industry, academia, government, etc., to collaborate and take forward this industry forward.